Good day, our wonderful learners at home, and you are welcome to Adewale Kayode online class. And this is a page where you can get 21st century content that can enrich your learning outcome in mathematics. We are still on our series looking into questions from our past Ssce. And let's see this question from Wassce 2020. If A is equals to multiples of 2, B is equals to multiples of 3, and C is equals to factors of 6. They are all subsets of a universal set. 1 is less than or equals to x, less than or equals to 10. When you see a question like this, you have all your sets have been given and the universal set. And don't forget that this your universal set is given in algebraic set notation. So you have to translate that. So in translating this is talking about 1 is less than equals to x and less than equals to what? 10. That means 1 is less than equals to x and x itself is less than equals to what? 10. So that means our x is greater than equals to 1 and our x is less than equals to what? 10. So here we are talking about numbers that are greater than or equals to 10. And what are numbers that are greater than or equals to 1? And what are those numbers greater than or equals to 1? 1 itself, 2, 3, 4, and you continue like that. Look at the second one. X is less than equals to 10. So that means we are talking about 10. Another number that are lesser than 10. 9, 8, 7, 6, 5. You see that all the number will now fall between 1 and what? And 10. So that means our universal set is equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, and what? And 10. So once you get your universal set, the next thing is now to look for the set. The first one is talking about set A. Is talking about multiples of 2. And when we are talking about multiples of any number, you don't need to constitute any fear. It's just like when you go back to your elementary class. At elementary class, they will ask the children recite 2 times, and they will start 2 times 1 2, 2 times 2 4, 2 times 3 6, 2 times 4 8. Recite 3 times, 3 times 1 3, 3 times 2 6, like that. Recite 4 times. So when they say multiples of 2, they are just talking about 2 times. So what are multiples of 2 now? That is 2. What else again? 4, 6, 8, and what? And 10. We'll stop at 10 because the universal set says between 1 and what? And 10. So let's see set B. Let me continue from here. Set B is talking about multiples of 3, just like multiples of 2. 3 times. 3 times 1, 3. 3 times 2, 6. 3 times 3, 9. 3 times 4 will be 12. And we cannot include 12 since the universal set is between 1 and what? And 10. So let's move to the last one, which is what? Set C. And it's talking about factors of 6. When we are talking about factors of any number, we are referring to numbers that can go in that number without remaining anything. And what are the numbers that can go in 6? 1 can go. What else again? 2 can go. 3 can go. And 6 itself can go in what? In 6. So we have said that. But don't forget the question says find A complement, intersect B complement, intersect C complement. That means we need to look for our A complement. And don't forget, anytime we are talking about complement of a set, we are talking about the elements that we cannot see in that set, but we have their presence in the universal set. Or we say universal set minus that set. That is what you cannot see in that set, but you have them in the universal set. So let's see this simple trick that I'm going to use now. I call this a simple trick in the sense that since we are talking about universal set and you take all elements from the set A. So let's list all elements in universal set. 1, 2, 3, 4, 5, 6, 7, 8, 9, and what? And 10. Now minus those in set A. What are they? 2, 4, 6, 8, and 10. Now let's now take them away now. Since we said what you cannot see in this set, but we have them in the universal set. So let's cross them. Number again, 6, 8, 10. So what are we left with? The remaining number now are 1, 3, 5. What is that number? 7, 9. These are the number that we cannot see in set A, but we have them in the universal set. So these are B complement. Again, your universal set, taking that your set away from that your universal set. That is, the element in B will be taken away from universal set. And that means those are the elements you cannot see in set B, but we have them in the universal set. So the universal set again, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And let's come and take set B away from them. Set B, 3, 6, and what? And 9. So let's take that away. Great. 3, 6, 9. So what are we left with? We are left with 1, 2, 4, 5, 7, 8, and 10. Now let's go to C complement now. C complement. That is our universal set minus set C. So let's pick our universal set again. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Take set C away from that. So what are set C? 1, 2, 3, and what? And 6. So let's see our element that will remain now. 1 will go, 2 will go, 3 will go, 6 will go. So we are left with 4, 5, all right, 7, 8, 9, and 10. These are C answer now, which is A complement intersect B complement intersect C complement. That is the element we can see in both A complement, B complement, and C complement. So what is common? Like I told you, the best method to find intersection of two or more sets is to look for the smallest one. That is the numbers of the element, the one that is small among them, the smallest among them. Now when you look at this one now, if you look at this, the numbers of elements in A complement will be what? 1, 2, 3, 4. Numbers of elements in B complement, 1, 2, 3, 4, 5, 6, 7. Numbers of elements in C complement, 1, 2, 3, 4, 5, 6. Now which one is the smallest? 4. So you use that 4 to determine the intersection. So we are going to determine the intersection from the smallest one. That is, we'll be considering the numbers inside the smallest one. 1, is 1 common to all of them? No. 3, is 3 common to all of them? No. 5, is 5 common to all of them? Yes, there is 5 here and there is also 5 here. So 5 is an intersection between the 3 of them. 7 is here and we also have here. So 7 is also what? Common to all of them. So we can now say A complement intersect B complement intersect C complement is equal to 5 and what? And 7. So I can now say the numbers in this element A complement intersect B complement intersect C complement now is equal to what? 2. That's the members of a set. So, but our final answer is A complement intersect B complement intersect C complement is 5 and what? And 7. If you find this video helpful, please subscribe to this channel and make sure you hit the notification button to get notification anytime we have a content that can assist you in mathematics. Thank you and God bless you all.